Batch 2, GRIETEEE A section. Project title is Smart Metering. Project guide is Mr. V.Vijayaramaraju, Associate Professor, Department of GRIETEEE. Project is Smart Metering. Smart metering is nothing but we are here designing a communication circuit to interface quasi-meter and PC. This is the communication circuit which we are using. And now let's start with quasi-meter. This is the quasi-meter front panel. It consists of 4 push buttons. One is reset and one is mode, and this is scroll up and scroll down button. The blinking of LED here indicates the kilowatt hour energy consumption of the load. Another feature of quasi-meter is it consists of 32 screens. In each screen it displays 3 parameters. Let's see here. This is the voltage VR, VY, VB, and by scrolling up and down we can keep on changing the parameters. This is the 3-phase voltage, and this is the current IR, IY, IB. The load to the quasi-meter is coming from the feeder section here. This is the 3-phase supply. Here we can see in each phase a CT is connected for stepping down the current. It steps down the current to 1 amps, which is compatible to the quasi-meter. The signals to the quasi-meter are coming via this cable here. Now this is the wiring diagram of quasi-meter. Here we can see TX plus and TX minus. This is specially for RS485 communication. Now we are using this port for communicating with the PC. Now I am connecting my circuit to this TX plus and TX minus. Here we can see 2 pins A and B. A is the non-inverting pin and B is the inverting pin. I am connecting TX plus to non-inverting pin and TX minus to inverting pin. This is MAX 485 chip. The function of this chip is to convert the incoming signals from quasi-meter to TTL logic. TTL logic is the output of the parameters coming from the quasi-meter, which are dynamic in nature, can be viewed in the front panel of this VI. This is the front panel and running it. Here we can see the address is being keep on increasing. The name of the parameter corresponding to each address can be viewed in the memory map of quasi-manual. This is the memory map of quasi-manual. Here we can see the address 93 and the corresponding output is 40803. Let us see in the memory map what the parameter actually is. 93 parameter is V.Yb and it has a This is a circuit for voltage and current signals data acquisition. The circuit is designed so that it can modify the rated 3-phase voltages and currents obtained from the supply of 415 volts 50 Hz in such a way that they can be given to the DSP. The DSP works only with inputs with values less than 3 volts. Also, the signals given as inputs to the DSP must be entirely positive, that is, there should not be any zero crossing in the signal waveform. The circuit here gives a DC sinusoidal output which has a peak-to-peak value of approximately 2.7 volts. The circuit we are simulating in multisim software. Now we are running. The screen of virtual oscilloscope shows both input and output waveforms. The sinusoidal waveform in blue shows the input waveform and the one in yellow is showing the output waveform. Here we can see that the output waveform is completely positive. This is the PCB which we have designed for voltage and current data acquisition. The 3-phase voltages are first sensed using 230 by 3 volts potential transformer. These are the potential transformers. And the currents are sensed using current transformers. The currents sensed are converted to voltage signals using a 100 ohm. This is the final output of voltage and current.